In Chapter 6, we are going to talk about gases, as you might guess from the title there. The quote here is from Maxwell. So many of the properties of matter, especially when in the gaseous form, can be deduced from the hypothesis that their minute parts are in rapid motion, the velocity increasing with the temperature, that the precise nature of this motion becomes a subject of rational curiosity. Don't really expect that to mean much to you. It'll mean more after the chapter. So I'm using slides here from the 4th edition. There's now a 6th edition, but I didn't want to make you buy the new one. The 5th edition, this section was titled Supersonic Skydiving and the Risk of Decompression. Really. But in the previous edition, it was called Breathing, Putting Pressure to Work. And I like this example better, so I'm sticking with it. We're all breathing, right? Nobody passed out yet. Do you ever think about how that works? How are we able to do that? How do we harvest oxygen out of the air and get rid of carbon dioxide? I mean, you're getting more complicated. How does our body turn oxygen into carbon dioxide? But that's way beyond this class. So here's a fun fact. Every day you move about 8,500 liters. So that would be like 4,300 2-liter soda bottles of air in and out of your lungs. That's a lot of air. That much air would weigh 25 pounds. Breathing is possible because our lungs are able to create pressure differences. So we can change the pressure of the air in our lungs, and because the outside pressure is constant, we can get air to flow in and out, and in and out, and over and over and over again. Well, what's pressure? This is a mathematical definition of pressure. Pressure is a force divided by the area over which that force is applied. The pressure we're talking about here is from individual gas molecules. And the quote gave us a little, spoiler here. Gas molecules are moving at a given velocity. Their velocity increases with temperature. And they're bouncing off of each other, and they're bouncing off of the containers. So as this little particle hits the surface, it exerts a force. The force is very small. The area is also very small. The pressure from that one molecule is very small, but this happens. I need numbers bigger than gazillion. What's bigger than gazillion? Quintillion? No, I think gazillion's bigger. Unimaginably huge numbers, like per second, that this happens. So the pressure, it's lots of little teeny tiny things, but it adds up. So it rained yesterday, right? One raindrop is not going to get very much wet. But if they just keep coming, right, you can get the whole sidewalk wet. Or if you live in, Arizona, you can cause a flash flood that can wipe out the road. Just little bits at a time added together. So that's what happens with the gas molecules making pressure. So the pressure that they make is going to depend on how many gas particles there are in the particular volume. You could think of that as the concentration. It's going to depend on the volume of the container and also on the average speed of the gas particles. And it turns out that this is related to the temperature of the gas particles. So what happens when you inhale, you drop your diaphragm, and that causes your lungs to expand. The volume of your lungs increases, which causes the pressure in them, pressure inside, to decrease. Now the pressure outside is greater than the pressure inside, and so air goes into your lungs to equalize the pressure. Then when you exhale, your diaphragm pushes up, compresses your lungs, that reduces the volume. Did I say reduce the volume before? It expands the volume. I don't know what I said. Anyway, When you breathe in, your lungs get larger, volume goes up, pressure goes down. When you breathe out, your lungs get smaller, smaller volume, higher pressure. Now the pressure inside your lungs is greater than outside, and so you're pushing the air out. Any questions?